everything works?
Yeah, we have.
I don't have any slides, so sorry for that one. So hi everyone, my name is Marcus. I'm a co-founder and I don't know, co-CEO. Co-CEO of Just Quantum. We have a booth over there. You can visit us there. So we do quantum software. So you see a lot of hardware providers here around, which a lot of different approaches, and we actually going the full way from up the end user, which is like our clients like Deutsche Börse, R&V Insurance Company, or Union Investment, for example, to the bottom of it, to the hardware, going what makes it usable on the systems, talking with our partners, Electron, for example, on how to actually make them usable, doing error correction on it, or different kind of scheme, error mitigation schemes, to actually run these algorithms which are somehow used in an industry like finance, insurance, or energy. And we do that by providing various kind of toolings, very kind of open source toolings, from building easy circuits to making more complex error mitigation schemes for specific chips on the specific hardware. And I was asked to give a bit more broader overview about the practical implications of this quantum computing for finance. It's quite a hot topic. It's written basically everywhere that quantum will revolutionize everything in finance, and we will have everyone a quantum computer on our end, and it will change the way we work with money, basically. So just on that side, maybe we can dial it back a bit. So we will not have these kind of implications, of course, in the future, because the system is man-created, just to make it clear. So it's not like quantum chemistry. It's a completely human-made environment. So everything is built to fix our needs in money markets. And there's always a hype around, for example, portfolio optimization. To going into optimization, you see a lot of different companies providing optimization schemes or optimization routines for quantum systems, which are all very in the research stages. And there is still a lot of discussions, even especially on the explainability of things. So, of course, when you are a bank and you manage things for other people, you need to be regulatory compliant. So all you're doing needs to have some kind of explainability to it, and there needs to be a human behind it to say, I take full responsibility for what happens. So going to that step, it's like this thing you do in optimization portfolio is more giving advice to it, giving an advisory to something, or even giving this robo-advisor, again, giving advice to a client who at the end needs to say, yes, I approve this kind of setting and I approve these kind of things. And going this direction there's quite a bit on the stretch of what actually can be optimized in this field. We have, on the one hand, we have asset allocation, which means we have allocation of already existing portfolio, which is quite important for bigger companies, which have already assets and constraints in what they can invest. So to find the right weights on the different kind of system, how much risk I want to take, how much return I want to get for it, it's one big part of it. And one big part of it is the constraints to it. And these are really the things we're really focusing on. Getting constraints properly in quantum systems is not an easy part, because one of the biggest kind of things floating around the optimization part is the so-called QO approach, which is an unconstrained approach. And when you have a system where really the constraints matter, it's quite hard to fit it into a system which has unconstrained in its name. So you use a language which is not made for it. So there to find different ways is quite an important step to bring optimization actually to running into this kind of system and into these kind of fields. Then the next bigger part in quantum or in quantum and quantum for finance is always machine learning. It will be always quantum enhanced machine learning or quantum machine learning, or how you want to call it. And there's one big part as well. So if you do use if you're a hedge fund and you just want to play a bit around, you can do whatever you want to. You can use the quantum machine learning algorithm and go fancy with it, even though it might take longer. Or you go for the banking and you actually manage again other people's money, and then you're going again into the regulatory problem. And then still a big point, even for classical machine learning, is explainability to it. Meaning, how do I explain actually what my algorithms does, and how do my decision focus on it? And as we are there as well on the early stages of quantum enhanced machine learning, we still have this hurdle to tackle and then going for the next one and make it all explainable. And on the other part, and this is one where we really focus on a lot on our research, is the simulation part. It's going from risk simulation, so how do I simulate certain assets, certain financial instruments. You hear a lot about option pricing or financial derivatives pricing, which is quite a hard task for computational efforts, meaning they will be used in classical sense. Monte Carlo simulations a lot, which run quite a long time to make it a proper assessment about the price of an object. In some exotics, so this is a very niche area. 2, risk management, meaning how is my risk from my overall portfolio, how is my business risk, like how is the impact of external factor, and this is how we can build up trees and actually manage to run simulations on it. And these kind of fields are very promising, but they're ranging from we need a full error-corrected quantum system because we have like a massive circuit to run. We cannot run it on a noisy device, but the actual advantages of using it are still in the research phase. So with our tools, we basically try to make it easy to frame these kind of business questions, to help companies to ask the questions and actually step out of the box and see where actually in the company might be an advantage, and then make a strategic advice to it. Thank you a lot for listening, and sorry that I don't have nice slides to show.
Thank you very much, Marcus. So, what are your questions for Marcus?
Thank you for seminar. So my name is Min Kwon from Max Planck Institute. So my question is my question is about the difficulty when we adopt the real market data to implement it to our quantum system. So what kind of difficulty do you handle right now to, for example, the stock market data to project to some solvable data of our quantum systems? And
that's a very good question. Actually, how do we get, it goes into the direction, how do we get this classical data actually in quantum data and then do something on it? Just when you look on the left, this guy has a tool built to it, so you can ask him for that. And of course, it's very hard and it's very overhead, which can destroy a lot of advantages you gain from the quantum algorithm itself. It can destroy by just the loading is way too long and way too complex. So it takes you more time to actually load the data into it before you can really do something to it. And what we have as our, that's why we like certain parts of risk management especially, is it's very less data you actually focus on and try to get into the system. You have less data, but a heavy calculation on top of it. Meaning, for one example is when we look at defaults or something like that, it's basically one rotation on the qubit. So it's just one probability you get into the system for one system. So you have 200 probabilities you need to get into the system, and afterwards everything is just heavy calculation. So these kind of low data, heavy calculation are the first adopters of these things, because you're completely right. To get these, it's still a very, very high challenge to actually get data into the system. I refer you to him, you can ask him later.
Do you have a comment maybe?
Yeah, I have a question also, but a comment. Yeah, we can talk about that.
Free advertisement for you. Free advertisement.
Yes, thank you so much. Yeah. There are people that say that Monte Carlo simulation is really not a bottleneck in the sense of computational complexity and performance. What do you have to say to that, basically?
Yeah, so it depends.
Closer, yeah.
Closer. He asked
that's good.
he basically asked that some people claim that Monte Carlo simulations are actually not the bottleneck, and there are other ways to mitigate these kind of hurdles. And of course, one big part, it's a lot of things in this bigger, like when we go for banking, the bigger culprits. One big thing is still digitalization. So there's a lot of processes which will actually be the longer processes and not the model execution and the model running itself. But for some high dimensional Monte Carlo simulation, there's actually an advantage to gain. And of course you need to check it with all the error correcting schemes and so on. If you not get an overhead for the error correction, referring to Google papers which show that quadratic speedups might not exist when you do error corrections to it. But in this special example, which we basically have published, there we look at a very high dimensional case of Monte Carlo. And there's actually, because it's a nested Monte Carlo simulation, so you have a Monte Carlo and a Monte Carlo and a Monte Carlo, it's quite difficult to on the and on the classical system to do it differently and scale it differently. So just on the ballpark figures, just to give you ballpark figures, so currently this model to run takes 15 minutes for them to go through one risk tree. And usually they want to change some parameters to see the stability of the things, and this would take always 15 minutes. So to run it just on a pairwise change of input parameters, it would take decades for them to actually run their full model. And then when we do that and transfer that, and actually from the beginning, the efficient loading of the probabilities into the system, we run the quantum amplitude estimation on it, then we just save already time and the efficiency of everything, like the full work stream. And that's basically the main driver for that one.
Okay, thank you.
Thank you very much, Marcus. Any other questions? We have still a little bit time. Okay, I have a question then.
Okay.
What do you think, from your perspective or from your prediction, what would be the first great application in finances?
I think I would have started my talk differently when I would give you the answer to that one. So there's a lot floating around, and again, on the hardware side, there needs to happen some, and you see a lot of researches to be done to get hardware proper running and get it through. And there needs to be advantages to really say, okay, now we're at a point where we really can make estimates on what will work properly and what will not work properly, because we're still not at this point. On the sense of what I would focus on now is, again, and we had the point with low data input, because we have in finance we have classical data. That's just a given fact because it's just human made. So low classical input and high calculations, and then focus on that one, and trying to figure out when there's a manual process in between, especially for the bigger banks, and usually they slow down the process and not the model itself.
Okay, and do you think that there are some processes in finances that are where the equations look a little bit like some quantum equations, or?
One thing about finance is they got a lot of physicists going into the system, and they were asked like, yeah, we have these problems, can you just do some modulation on it? And one which is of course given is in the derivative space, so where you calculate financial instruments, there's a lot of ideas from just basic nature getting into it, how to model these random walks, basically how they propagate and so on. So that's to that side. And in this sense, there was a lot of happening in finance, so to find the right language is still a case. So you need to find the language between the quantum people, like we're talking quantum, and then the finance guys who talk finance. Yeah, that's all still in the process and all part of the process to find the common phrasing. Even though on the mathematics side there's quite some similarities.
Okay, thank you very much. If we have no more questions, then I would call the next speaker.